Hello guys, let's remember a little bit what we studied last week. Free body diagrams, if you remember, are diagrams or representations of the acting forces on an object. And yes, basically, every object that we can think of in the universe can be represented with free body diagrams. It can be either a cookie, it can be an animal, it can be a person, so basically everything. We need to remember that a free body diagram is going to be represented by a box like this, and then the forces that are acting on that specific object. The first thing that we need to remember is that any object is being pulled down from gravity. The next force is going to be the force of surface or the normal force. Then we got the actual pull or push, and at the end we got the friction that goes on the opposite direction. So the one that pulls down, that's gravity. The surface goes the opposite as gravity. Then the actual pull or push. And the last one, it's going to be the friction. So basically, any of the objects that we have over here, any of these objects can be represented by a free body diagram. Okay, so let's practice just a little bit. Let's get any of these objects. Okay, let's get this hat. So I'm going to represent the hat with my box. The first force, never forget it, the first force is going to be gravity. And since forces come in pairs, has to have another one like this, which is going to be the surface force or normal force pointing up. And that's it. We're not going to use any other arrows or forces since the hat seems to be balanced without a change in motion. But it's not going to be the same thing if we got the animal on the side of the hat that seems to be moving forward. We're going to put it over there. Gravity, it's already there. Normal force or surface force is there. Then we get the arrow that is going to point on the direction of the movement, but of course we're going to have the friction. Let's say for this case that the animal is just running at the same speed. If for some reason we know that the animal is not moving at the same speed, then we'll need to make a change. In this case, if it's accelerating, the size of the arrow will be longer. Okay, so now it's gonna be your turn. You can pick any of the objects that I'm showing you right now and draw the free body diagram for this object. Teacher, at this moment, please stop this video and let the students create the free body diagrams for 1 or 2 minutes. Thank you. Okay, now in 30 seconds, discuss your neighbor's free body diagram and your free body diagram with your neighbor. 30 seconds. Teacher, please stop this video. Okay, let's see something a little bit more complex, real life. As stated before, any object can be represented with a free body diagram. In this case, geese are flying at a constant speed. let's stop it, and let's go ahead and create the free body diagrams, the free body diagram for one of these birds. So just FYI, I'm gonna put the box over there. Is it gonna be 2 forces acting on the object or 4 forces? You got 1 minute, and please, teachers, at this moment, stop the video. Okay, I hope you got it. The first force, as always in this world, is gonna be gravity. Second force, the surface force or the normal force. Since the geese are flying in this direction at a constant speed, we're gonna put that arrow over there, and the force of friction or friction is gonna be opposite as the push or pull. As you can see over here, they're balanced forces. That's why the arrows have the same size or magnitude. Okay, let's go ahead and see another video. An airplane taking off with an air carrier, a lot of acceleration. Let's see another one. And we stop it. Why? Because we're gonna go ahead and we're gonna create a free body diagram for the plane. So this box is gonna be our actual object. Go ahead, you got 1 minute. When you finish, discuss it with your neighbor and see who's got the correct answer. Teachers, at this moment, please stop the video. Okay, I hope you got it. So the first force, as always, it's gonna be gravity. So this is gonna be gravity. We got the normal force or the surface force over there. We got the push or pull on that direction and the friction on the opposite way. You got it like this? Well, this is gonna be wrong. If you got it like that, it's gonna be wrong because it's accelerating a lot. So actually, what we should do is something like this. It's an unbalanced force. So the arrow that is going towards the movement or in the direction of the movement is going to be longer. Got it? Excellent. Then the next video, you're going to see how an airplane lands. So it's moving, then stopping. A lot of speed and then stopping. Same thing with this one. Look at the cable down below. It's gonna stop that airplane. So go ahead and draw the free body diagram for this airplane that is about to stop. You got 1 minute, and if you're finished, discuss it with your partner. Teachers, at this moment, please stop the video. Okay. Hope you got it correctly. We got gravity. We got surface. So we got surface. We got this arrow that we're going to discuss what is it. But we know, as of now, we know that that cable over here, as you can see it over here, that cable, it's doing a big pull so the airplane can stop. So in this case, since it's going to be a big pull, we're going to represent it like that. And the friction stays the same size. Got it? Excellent. Okay guys, so I hope you enjoyed the video, that you learned something. As you can see, as you now know, every object in the universe can be explained with the free body diagram, the forces acting on that particular object. Remember that science rocks.
remember, guys, science rocks. Merry Christmas!